It makes perfect sense.
Evaluate. Let's start with something simple.
Whoa.
Okay.
I don't remember
This
this.
is pre-cal. You should remember this. We have arc sine, arc cosine, arc tangent, arc. Way that I will survive this review without killing someone if you're going to be this noisy. I'm exhausted. I've been here since 6:30. Some of you have as well, I know, but let's be quiet, please. Okay, arc sine is opposite over hypotenuse. Remember, we have to say between negative pi halves and positive pi halves for arc sine, so that means our answer would be negative pi 6. Okay? Try this one. Find the arc cosine. There's not, you don't need 3 C's though. Of 1. Find the arc cosine of 1. First and second. If cosine's 1, it has to be on an axis, so we're looking for what? The x or the y coordinate? The x coordinate for arc cosine. So that would be this one here. The name of that angle is 0. Remember that if arc is out in the front of the problem, that means you're asking for an angle. Okay, it's the arc angle. Okay, how about this one? Arc tangent of negative root 3. Find the arc tangent of negative root 3. First and fourth, okay. We're going to choose number 4 because it's a negative tangent value, so that would be negative root 3 over 1, which means that the 60-degree angle, so that is negative pi thirds. Okay. Of the arc secant of root 7 over 6, over x. Sine of the arc secant of root 7 over x. Set it up in quadrant 1. Arc secant, well, secant is the sha in Choshakao, right? So that's hypotenuse over adjacent. So if we do Pythagorean theorem, we're going to say x squared plus maybe b squared equals root 7 squared. So b squared would equal 7 minus x squared. So b is the square root of 7 minus x squared.
Yay.
Therefore, so this is the square root of 7 minus x squared. So the sine of that would be opposite of hypotenuse, which is root 7 minus x squared over root 7. And since they're both roots, you could, if you wanted to, be the square root of all of it. 7 minus x squared over 7.
Do you have to do that?
No, you just can. You can just, yeah. 1, right? Because it's a positive tangent value. Tangent is opposite over adjacent. If I do Pythagorean theorem, 1 squared plus 3 squared equals c squared. That would be 10 equals c squared. So c is root 10. So the secant again is the sha in Choshakao. So that would be hypotenuse over adjacent, which would be root 10 over 1, which is just root 10. Simple. If this function is strictly monotonic, justify your answer. Using calculus, determine if this function is strictly monotonic. Meaning don't just draw a picture. I want you to use some calculus. If all else fails, take the derivative and set it equal to 0, right? 3x squared minus 12x plus 12. I can factor out a 3. So that leaves x squared minus 4x plus 4. Which gives me x minus 2 times x minus 2. So I have a critical number at x equals 2 if I'm setting this equal to 0. Okay? So we're going to test both sides of this. We've got 3, I've got x minus 2. That's squared, because there's 2 of those factors. So if I plug 0 in, what am I going to get? Positive and positive. If I plug 4 in, what am I going to get? Positive and a positive, which means what?
Monotonic.
It is monotonic, yes. Why?
Because it doesn't change sign.
Because f prime of x has no sign change. Meaning that the slopes are always positive, so it would pass the vertical line, or the horizontal line test. Quotient rule, so I go low, high prime is 1 over x. So low high prime minus high, what's low prime? 1 over low squared is x squared. So I would get 1 minus the natural log of x over x squared. Okay, so what am I testing? Huh? How do I find critical numbers off the first derivative? Equal to 0 or what? Can it also be undefined?
Guess and check.
It could be undefined as well. So 1 minus
Critical
natural log of
value.
x would make the thing equal 0. What would make it be undefined? If x equals 0, then g prime is undefined. So we have to check both of those. Okay. So if I get 1 equals the natural log of x, let's see, if I do exponentiate both sides, we get e to the 1 equals e to the natural log of x, so e to the first would equal x. So I have two critical numbers here, 0 and e. One factor, and then x squared is the other. Well, isn't x squared always positive? So we can just put plus, plus, plus across there. How about give me a number between 0 and e? 1. Okay. Natural log of 1 is 0. 1 minus 0 is positive, so that's positive. Okay. Give me something bigger than e.
5.
5.
I like a million. Natural log 1 minus natural log of a million. Is that probably negative?
Yeah.
Yes.
Yes, it
I mean,
is.
it depends.
Wait, so can't we just stop there since we know it's negative? It's gonna change.
Well, yeah, let's just make sure that everyone understands why. What if I plug in something that's easy to evaluate, like e squared? What's the natural log of e squared going to equal? 2. So that would be 1 minus 2, which is negative 1. So that's negative 2. So this is...
You already know.
Okay. Now, I just have a really quick question. We can stop here, but tell me about what if I plugged a negative number in?
You're going to get
Yeah.
Can I plug a negative number into this particular thing? Why not?
You,
0. So because the domain of this original function is x is greater than 0, we don't have to actually worry about anything over here. Look at the domain of the original function. We should test 0 just to be safe because that's not always going to happen. But in this particular case, we can't go past 0, right? Because it's going to be undefined no matter what we do. So this is not monotonic. Why?
F prime has
Because f prime of x has
G prime. Oh, it is
g prime of x has a sign
change.
f of x equals x cubed minus 4 over x. Find trying to make sure that I have the right problem right now. F inverse prime of 6.
Do you guys come up with these problems, or do you get them from somewhere?
Sometimes I make them up, but usually I get them out of one of my calculus books. Over what? F prime of f inverse of x. Okay, can I solve for y or x in this equation? Can I find f inverse? Is that going to be easy to find?
No.
So let's just use the formula. Okay, so what I like to do, and I think this is helpful for those people that need to see things, write the formula down and then rewrite the problem again. F inverse prime of 6, plug the number in. Okay. We're trying to find f inverse prime of 6, so let's rewrite it with the number in the parentheses. So that's 1 over f prime of f inverse of 6. Okay, then we start to work from the inside out. We need to find f inverse of 6, right? So f inverse of 6 equals something. Yes? Which means that f of something equals 6. So we need to set our original equation equal to 6, and they're usually set up to guess and check until you find something simple that works.
Oh, yeah.
Does 0 work? Does 1 work? It'll be -3. Does 2 work? 2 cubed is 8, minus 4 over 2 is 2, 8 minus 2 is 6. So x equals 2 will work, which means that f of 2 equals 6, therefore f inverse of 6 equals 2. Okay? So I'm going to replace the innermost parentheses with what? 2. That's the little puzzle bit, and then you need to find f prime of 2. Now, should everybody in this room be able to find f prime of 2?
Yeah.
Yes.
I
If
really
you have
hope
any
so.
self-respect at all, you should be able to find f prime of 2. So let's find f prime of x equals, let's see, I'm going to rewrite this as x cubed minus 4 times x to the -1. Okay? So if I take the derivative, I get 3x squared plus 4 times x to the -2. So that's going to be 3x squared. Do not try to evaluate anything with negative exponents. Simplify your negative exponents to make them positive and then evaluate. Okay, so this is plus 4 over x squared. So let's find f prime of 2. So I've got 3 times 2 squared plus 4 over 2 squared. 3 times 4 is 12 plus 4 over 4 is 1, so that is 13. Please don't circle this as your final answer. It's 1 over that number 13 is your final answer. Who got that one right? Okay, fearless. Should we try another one? Jacob?
Yes.
Oh, sorry, my brain just stopped. Okay, sorry. Square root of x minus 4. It literally just came to a crashing halt there. Okay, find f inverse prime of 2. I have it memorized. F prime of f inverse, right? So we're trying to find f inverse prime of 2, which is 1 over f prime of f inverse of 2. So we start on the inside. F inverse of 2 equals something, which means that f of something equals 2. You go through the same process every single time. Okay, so square root of x minus 4 needs to equal 2. Can we guess something, or can we solve that? Yes. We can guess, okay. Square root of 4 would give me a 2, so I need to have a 4 inside, so that means x needs to equal 8. So f of 8 is 2, therefore f inverse of 2 equals 8. Okay. So I got 1 over f prime of f inverse of 2 is now going to take on the persona of an 8.
Yeah.
Okay, and then we need to find f prime. So f prime of x, remember this is x minus 4 to the 1/2. So I need to take the derivative of that carefully. So I'm going to go 1/2 to the -1/2, and then I leave the inside alone, it's chain rule, times by the derivative of the inside, which would be 1. So basically I'm doing 1 over 2 times the square root of x minus 4. Clean it up before you try to evaluate it. Okay, your brain's going to melt down if you try to simplify negative exponents or evaluate negative exponents. So I got 1 over 2 times the square root of 8 minus 4. That would be 4. Square root of 4 is 2. 2 times 2 is 4. So f prime of 8 is 1/4. Right? So 1 over 1/4 is going to give me what? 4. That is your final answer. You got that one right.
Yeah.
Much